using common multiples and common factors. So we're going to use both of those to solve some problems. Today's I can solve problems using common factors and multiples. So make sure you have today's date, your I can, page number, and you're ready to move on. All right, let's dig in with some factors and some multiples. So we're going to go through some different scenarios and talk about some possibilities here. First one we got, Elena is buying cups and plates for her party. Cups are sold in packs of 8 and plates are sold in packs of 6. She wants to have the same number of plates and cups. So what's a number that would meet her requirements? Yeah, there's a lot that she could do, right? She could do any of the possible numbers that match up between 6 and 8, right? But what would be the smallest number that she could do? In other words, what's the least common multiple here? Yeah, it's 24, right? Because that's the first number that 6 and 8 both make. How many is she going to need of each of those? Yeah, she's going to need 4 packs of plates, as well as 3 of cups. So what other ones could she do to make her requirement that she have the same plates and cups? Yeah, she could do 48, because 6 times 8 is 48. 96. There's a ton more numbers that we could do, right? It would be just looking at the multiples of 6, multiples of 8, and where they match up again. Okay, let's move on. Let's look at tiles in a restaurant. Restaurant owner is replacing the restaurant's bathroom floor with square tiles. Tiles will be laid side by side to cover the entire bathroom with no gaps, and none of the tiles can be cut. The floor is a rectangle that measures 24 feet by 18 feet. What is the largest possible tile she could use? So what are we going to need here? We're going to need a greatest common factor, right? Because we need something that can break up both of those equally, because we can't cut up the tiles. So we need to think about our factors of 24. We got 1 and 24, 2 and 12, 3 and 8, 4 and 6, and that's all of them. And then our factors of 18 are 1 and 18, 2 and 9, 3 and 6, and those are all the factors there. So if we look at both of these, looks like our greatest common factor is, 6. Those are some giant tiles. But if we go by side length of each square being 6 feet, it will work for what we're talking about. So each square would have to be a 6-foot long side. And how do we know this? Well, 6 is the largest number that can divide equally into 24 and 18. So how many are we going to need of this largest size? Well, 3 will go along the 18 side, and we can make 4 columns across. So we're going to need a total of 12 tiles. These are enormous tiles. What else could we use? Well, we could make them 1 foot, right? So 1 foot would work. 2 feet would work because there's a 2 in both of them. We could do 3 because that's in both of them. And that's it. Those are the only other ones. So 6 foot is the largest. Obviously, we could go down into 1 foot ones, or 2 foot or 3 foot, but based on what they said, 6 foot would answer that question. Let's look at some stickers. So, first day of spring, Lynn is putting stickers on some of the 100 lockers along one side of her middle school's hallway. She somehow doesn't get in trouble for this. No, she puts a skateboard sticker on every 4th locker and a kite sticker on every 5th locker. So what are 3 lockers that are going to get 2 stickers? Yeah, it's going to be wherever we get the same count, right? This is just going to be common multiples. Woo. All right, let me use the InstaSolve. Okay, so we get a line up here at locker 20, right? Next locker we line up on both of them is locker 40. And I only did part of these, but you can see that we go to 60. What other ones would get them? Yeah, you can see it's every 20 that we're going to do it. So locker 80 and locker 100 are all going to end up with 2 stickers. After Lynn makes her way down the hall, will the 30th locker have no stickers, 1 sticker, or 2 stickers? Well, 30 is not a multiple of 4, but it is a multiple of 5, so it's going to have 1 sticker. And the way we know that is because it only has 1 of the 2 possibilities. 1 stickers? 1 sticker. It only has 1 of the 2 possibilities. 4 is not a factor of 30, but 5 is a factor of 30, and that's how it's going to end up with 1 sticker on the 30th locker. The school nurse is assembling first aid kits. She has 75 bandages and 90 throat lozenges. All the kits must have the same number of each supply. All supplies must be used. So what's the largest number of kits the nurse can make? Well, here we're going to have to look for a common factor because then that'll tell us how many kits that she can make. So let's get the factors for each of these. Factors for 90, obviously 1 and 90, 2 and 45, 3 and 30. Let's see, what else? 5 will go into it. 18 times? Can do 9 and 10. I think that's all of them. Yep, I think I missed one. Can't 6 go into it? Oh yeah, 6 and 15. Let's see, what else? 7, no. 8. No, not equally. 9, we got 10. Okay, and then everything starts repeating. All right, let's get our other ones. All right. Obviously 1 and 75. 5 and 25. Let's see, 3 and... I know what I did wrong. It's not 5 and 25, it's 3 and 25. And then it's 5 and 13. I think that's all there. So we look at greatest common factor. Oh wait, it's not 13, it's 15, isn't it? Eek. I need to practice my factors a little bit better. Yeah, 13 would have made 65. It's got to be 15. Okay. So let's see. Oh, hey. Looks like 15 is the greatest common factor of both of them. So we can make 15 kits. That's going to be 5 bandages and 6 lozenges for each one. That makes sense that it would be that way, because 5 times 15 is 75. One more 15 would make 90. So yeah, there we go. All right, let's wrap up here. So greatest common factor, what is that? Yeah, remember that is something that two numbers have in common that can divide into both of them equally. In other words, when you divide it in, you get a whole number as a quotient. What type of situations did we find with the greatest common factor? Well, we talked about it with, maybe for the party, but definitely when we're talking about the nurse and that situation. When you're working with fractions or not fractions, excuse me. Well, yeah, fractions when you're multiplying and you're trying to cross cancel and you're looking for numbers that they have in common that you can divide out quickly. What about least common multiple? Yeah, again, that would be like converting with fractions. Things like for prizes, so you know how many that you need, or if you were trying to make sure you got a double prize. Least common multiple, remember, is that smallest thing that both can multiply by another number to make. Like 4 and 5 can both make 20. 6 and 9 can both make 18, and that's their least common multiple. All right, I think we are good for now. Hey, thanks for watching.